11 chemistry students. Today what we are learning about again is chemical reactions, identifying different types of chemical reactions, and in particular we are learning about today single displacement reactions. So here we go. Okay, single displacement reactions. We're going to learn how to predict the products of these, but first we have to define what a single displacement or reaction is. What it is when one element in a compound is displaced by another. The general rule is the following. AB plus C equals AC plus B. Now who's competing here? If we take a look, you can see that B and C are in red and they're competing for A's attention. Okay, so in this case we would say A is the metal because it's written first and B is the non-metal, so it's written second. So we can say that B and C are also non-metals competing for A's attention. But the best way that I can explain this is the following. We have to go back in time to 2005 when Brad and Jennifer were an item. Well, as a matter of fact, they actually weren't an item after 2005 because the following happened. This lovely lady right here is Angelina Jolie, and if you recall, something happened in their relationship on the set of a movie. Well, if we want to define this as terms of chemicals, we can say that Brad, because he's written first, he is the metal here, and we have two non-metals competing for the attention of Brad Pitt here, okay? So who's going to win? Well, the answer is the more attractive non-metal. So if you recall, what ended up happening is that Angelina got to go with Brad because she is more attractive than Jennifer Aniston. So of course it didn't turn out all that great for Jennifer Aniston. As you can see, she's kind of asking, what the heck happened? Well, let me tell you what happened, Jen. Angelina is more attractive, so therefore you lose, unfortunately. So just like males and females can compete, metals and non-metals can compete with each other as well. Let me explain what I mean. So there's two types of competitions that can happen. The first is metal replacing a metal cation in a compound, as follows. I'll give you an example. Here we have lithium and silver chloride competing, but it's the silver and the lithium that are going to compete. Now, if lithium is more attractive or reactive in chemistry, lithium gets to go with the non-metal. We got to watch the charges here. That balances out good. And poor old silver is kicked out on its own. The same thing can happen with non-metals. Now, usually we focus on halogens in this course. If sodium chloride comes across fluorine gas, what will happen is fluorine is actually more reactive than chlorine is. The chlorine is going to end up getting kicked out. Remember that chlorine is diatomic, and you end up getting a new metal-non-metal pair. The charges cross over, it's 1-to-1 NaF. So lithium, again, a metal can replace another metal like so. Lithium and potassium are going to compete. If lithium is more reactive, lithium will end up going with the partner and potassium gets kicked out. Now, metals can also replace hydrogen because remember, hydrogen, even though it's a non-metal, it can act as a metal. It can either be replaced in an acid like the first example or like water. Now, it's easier to replace an acid hydrogen than it is from water. The hydrogen from water, and we'll explain in what scenario that happens. But if we take a look, we will replace that hydrogen with lithium, and hydrogen gets kicked out on its own, which is a diatomic thing on its own as well. Same thing can happen with hydroxide, gets kicked out like so, and we get a similar situation. Of course, you have to balance that out, but that's what that looks like right there. So let's determine what metals are more attractive or reactive than other things. Well, what we need to look at is the metal activity series, okay? And this will tell us whether a displacement will happen or not. Now, if we take a look here, we have a single lone element and we have a metal and a polyatomic nonmetal. You can see that these guys are going to compete with each other. So let's look at the metal activity series, which is on the back of your periodic table. So your metal activity series is located right here on the back of your periodic table if you take a look. So we are looking for iron and we are looking for copper. And copper is way down here. and iron is way up here. And as we go up, we go to the most reactive. So iron is more reactive than copper. Now the interesting thing here is as well is if you don't know what charge iron will have, it's going to have a 2+ charge. It's not going to have a 3+ charge. When it goes from no charge to a charge in a single displacement reaction, it will always form an iron 2+ charge. So will this reaction proceed? The answer is yes, it will proceed because iron is higher than copper. It is more attractive than copper is. So in this example, iron is Angelina Jolie and copper is Jennifer Aniston. So iron gets to go with sulfate and copper gets kicked out on its own. Now we have a choice between 2 and 3. Remember, it will form 2 because that's what it says on the activity series. This crosses over, so these charges cancel out. We then just have to balance, and this is exactly what is formed. So next what we're going to look at is silver and calcium chloride. Now we know these are the two metals, so we're going to see if they can compete with each other, and if silver is more attractive, it will win out over calcium. Let's take a look at the metal activity series. When we look at the series, we can see that calcium is located way up here. And the other thing that we're looking at is silver, which is located way down here. So calcium is already with the pair and silver is way lower. So that means calcium is going to win out over silver. As a result, we are going to get NR, or no reaction, because silver is higher than calcium. Another important thing to note is that any substances that are above this, that are in this group here, there's a little space there. These guys can react with acids to form H2. This group here at the top can react with water and form H2. And finally, this last group, the least reactive group, acids and water will not react with it very well at all. And so they won't break down at all. So these elements down here, silver, gold, platinum, they're all our valuable metals because they're unreactive. They don't break down in acids to form hydrogen gas, and they don't break down in water for sure to form hydrogen gas either. Now remember, it's not just the metals competing with each other. Non-metals can compete with each other too. And normally we just focus in on halogens. The most reactive halogen is fluorine, and to the least reactive halogen is iodine. So let's take a look at the periodic table as well to remember this. If we look right here, here is my halogens. Nice arrow there. Take a look at that. This is the most reactive one here, and this is the least reactive. So that means that fluorine can displace chlorine, bromine, and iodine can't replace any of the other ones. It's unable to react because it's the least reactive. So if we look at this example here, we have I2 plus calcium, Br2. Will this reaction happen? We know iodine is the least reactive. Bromine is higher or more reactive than iodine. We can say that no reaction happens. For tomorrow, what you're going to do is you're going to predict the products of these two single displacement reactions. Please bring it prepared tomorrow. This is what I'm going to check for your notes. Hope you've enjoyed the video and hope you've learned something. Please post a comment to Schoology if you have any questions or ask me tomorrow. Thank you and have a nice night.